Dot School presents Right Pyramids, Cones and Spheres 1. A pyramid is a solid figure with a polygon base. So this is the base of the pyramid. As you can see, it's a polygon. It's a pentagon with 5 sides in this case. And triangular faces. These are the faces that are triangular in shape that meet at a common point. It's this point I'm referring to. The common point is referred to as the apex of the pyramid. So this point is called the apex. So we have the apex. We have the triangular faces. And then this one is the base. A right pyramid has its apex directly above the center of its base. So if you locate the center of the base and go right up from there to find the apex, the pyramid is a right pyramid. If not, if the apex were to be shifted so that it were closer to one of the sides on the base, it wouldn't be a right pyramid. We are going to talk about right pyramids only. There are a few things you want to remember about pyramids. Each one of these points is a vertex and they're called the vertices of the pyramid. And that includes the apex. So these are called the vertices. Plural for vertex. Each one is a vertex. The triangular faces that you see are often referred to as the lateral faces of the pyramid. And of course the base is also a face of the pyramid, but it's not a lateral face. And then these straight lines that join two vertices together, either two vertices on the base or one vertex from the base with the apex, they are called the edges. So we have these as edges of the pyramid. I'm going to write that down. So these are all the edges, and there are more. The blue ones are all the edges. I've just shown you a few of them in red. So these are the edges. If the base of the pyramid has got n sides or n vertices, there are going to be n plus 1 vertices in all on the pyramid, because you have n vertices on the base and add one vertex, which is the apex of the pyramid. Similarly, a pyramid that has got n vertices on the base have got n plus 1 faces. You have n of these lateral faces or the triangular faces, there are n of them, and then you have one face which is the base, which makes it n plus 1. And then of course you have 2n number of edges on the pyramid. You have n edges on the base and then another n edges that form a part of the triangles joining the base with the apex of the pyramid. Let me then write that down. If you have a polygon on the base that's got n sides or n vertices on the base, that means the pyramid, like I said, has got n plus 1 vertices. One extra vertex, which is the apex, and n plus 1 faces, and 2n number of edges. The distance from the center of the base to the apex is called the height or the altitude of the pyramid, often referred to as the letter h. And the distance from the center of any of the sides on the base from the apex, let me just make a line there. This is the distance I'm referring to from the center of any of the sides on the base to the apex. This is called the slant height of the pyramid, often referred to with the letter S. The lateral surface area of a regular pyramid, that is a pyramid in which the base is a polygon with equal sides, is given by the formula lateral surface area is equal to 1/2 times the perimeter of the base. So this stands for, P stands for the perimeter of the base. Perimeter of the base times the slant height S. In other words, if you add up the areas of each one of these triangles together, the area that you get is called the lateral surface area of the pyramid. And when you add the lateral surface area to the area of the base, which is a polygon, you get the total surface area of the pyramid. So we have total surface area is equal to the lateral surface area plus the area of the base. And that's pretty logical. The total surface area of the shape is going to be the surface area of each of these triangles plus the area of this polygon on the base. I have to say here that the base can also be a triangle. Let's not forget that. If the base is a triangle, we call it a triangular pyramid. If the base is a square, we call it a square pyramid, and so on. And finally, the volume of a pyramid, V, is given by the product of 1/3 times the area of the base multiplied with the height H of the pyramid. A cone is a pyramid with a circular base. As you can see in this picture, there's an apex, just like any other pyramid, but the base is not a polygon, it is a circle instead. Let us say the radius of this circle is R. The height of the cone, that is the distance from the apex to the center of the circle, is denoted by the letter A. So H is the height. And the distance from the apex to any point on the circular base is S, S for the slant height. Now if you look at this triangle in orange over here, you'll come to realize that there's a right angle over here, which means we can apply the Pythagorean theorem on this triangle. The formula is the square of the hypotenuse, the slant height is the hypotenuse of this triangle, is equal to the sum of the squares of the other two sides. Therefore, S square is going to be equal to H square plus R square. So if you know any two of these, you can easily solve for the other one. As a circle does not have edges, the perimeter of the base is the circumference of the circle. We know that for a pyramid, remember, a cone is just a special type of a pyramid in which the base, instead of a polygon, is a circle. The same formulas apply. The lateral surface area is going to be equal to 1/2 times the perimeter of the base, which is the circumference of the circle given by 2 pi r, where r is the radius of the circle, multiplied with S, which is the slant height. If you want to find the total surface area, all you need to do is add the lateral surface area with the area of the circular base, which is given by pi r square. And the volume of a cone is equal to 1/3 the area of the base. Remember, that's the general formula for any pyramid. 1/3 the area of the base. The area of the base is pi r square times the height, which is H. So we have 1/3 pi r square H as the volume of the cone. A solid that's perfectly round and looks the same from every direction is called a sphere. Now the only attribute of a sphere is its radius r. The larger the radius, the larger the sphere is. The surface area of a sphere is given by the formula 4 pi r square, and the volume of a sphere is given by the formula 4/3 pi r cubed. We have learned quite a few things about pyramids, cones, and spheres. Hope you remember them and be able to apply the formulas in problems.